Hello, mathematicians. This is Mrs. Shopper coming with you a couple more ways to prove triangles congruent. Today we're going to be talking about angle, side, angle, and angle, angle, side. So you notice we're using some abbreviations. So yesterday was side, 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 and side, angle, side. These are going to be looking at angle, side, angle, and angle, angle, side. So here you go. Whoops. Perfect. Okay, so here we go. Notice the note card next to it. It means that I need you to be copying this on your note card. Just like when we did side, angle, side yesterday, the angle had to connect the two sides. When we're doing angle, side, angle, the side has to connect the two angles. Okay, and so when you look at this picture, we see the parts that correspond, and then the side is the one that connects them. And it's really important that you correspond your sides when you're writing your congruent statement. Here's your congruence statement. Okay. So here, let's talk about, can we prove that these two are congruent? So L is the midpoint of WE. So we know from the midpoint theorem that if L is the midpoint of WE, we know that WL and LE are going to be the same measurements, okay? Because of the midpoint theorem. Then we know that WR is parallel to ED. So WR is parallel to ED, okay? Now, with that in mind, here's something I want you to think about. When you have two parallel lines intersected by a transversal, we can use alternate interior angles. Now that came from chapter 3, so that wasn't that long ago. Alternate interior angles are coming back because here is my transversal, all right? And I've got, oh, there's a little lag in the video. My transversal should be highlighted. There we go. And so we can then say with that angle W and angle E are congruent because of the alternate interior angles theorem. Okay, so theorems prove the angle relationships, converses prove lines parallel. So I can say that angle W is congruent to angle E because of the alternate interior angles theorem. Okay, it's important to give my reasoning. All right, we can say that WL is congruent to LE because of the midpoint theorem. Okay, it's important to give our reasoning. And then I can also say, because of the vertical angles theorem, I can say that angle RLW is congruent to angle DLE because of the vertical angles theorem. And again, we have to back up our reasoning, and there's a little bit of a delay coming into the video. We have to back up our reasoning. We've got to use those theorems and postulates and definitions that we've been learning about all year. They keep coming back. You know, and as you're creating your note cards for Unit 4, Chapter 4, feel free to create the note cards. Like if you're like, oh, I forgot the alternate interior angles theorem, throw it on a note card. We want you to keep practicing them. We want you to remember them. It's going to take time and practice. You're all capable of doing this. We need to be willing to put in the time and the effort to do it well, because remembering it simply for the test isn't going to work for us this year. You have to be able to retain it throughout the whole year. Okay, so we can then say that those two triangles are congruent. The other way to prove triangles congruent is angle, side, angle. I'm sorry, angle, angle, side, AAS. And that's saying that you have two angles in a row and then a side. So when you say all of these, like side, 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 angle, angle, side, angle, side, angle, angle, side, it means it goes in this order. All right. So angles, then side. Now, keep in mind that it is never, ever appropriate to swear in geometry. There is never an angle side-side. Nor is there ever a side-side angle, okay? So when you complete your assessments and you put an answer down and it's a swear word, don't write it in reverse because it's still going to be wrong because we don't ever use ASS or SSA in geometry. Just saying. All right, so here we go. Can we prove that LN, oh, this is a good one. Okay, if angle NKL is congruent to NJM, you know what? Okay, so those are congruent. And KL is congruent to JM. Can we prove that LN is congruent to MN? Okay, here's what I need to do. I need to reimagine this. And I just realized I made a mistake here. This isn't the right one. This is the right one. Anyone else catch that mistake that I made? I caught it. We're good. We're good. All right, what I'm going to do is I need to draw out these triangles a little bit differently. I need to separate them a little bit. So I'm going to call this J, this N, and this M. And I'm going to draw another one. And I'm going to call this K. I'm going to call this L and this N. And then, so I'm redrawing it out. So J and K are congruent. And JM and KL are congruent. We want to know if these two sides are congruent. Okay. So one other thing that I know, I'm going to shrink this down and bring it over here. One other thing that I know is that this angle right here is congruent to itself because of the reflexive property of congruence. So I'm going to say that angle N is congruent to angle N. Okay. And the reason I can say that angle N is congruent to angle N, again, using my proof, is because of the reflexive property of congruence. Okay. When I look at these, I see that I have angle, angle, side, angle, angle, side. So I can say that triangle NJM is congruent to NKL because of angle, angle, side. And you might say, well, that's not what the question's asking. It's asking if LN and MN are congruent. And here's the thing. By saying that those two triangles are congruent, I can then say that these two sides are congruent because of corresponding parts of congruent triangles are congruent. I was able to get to a point where I could prove the triangle's congruent. And then from there, I could say that their parts were congruent. Fantastic stuff. Fantastic. So you're going to get a chance to practice. We did not assign any proofs. I think talking about them in class is great, but we didn't assign any. So you've got 4 problems to work on tonight and practice. Let me know if you have any questions. Until next time.